Starting from the late 17th century, the bicycle, commonly known as bike, began to be utilized in police activities. In fact, during its early exposure in New York City, with a 29-man unit, was able to arrest 1,366 criminals in its first year. These patrol bikes perform a very important role in police officers' operations and procedures. They are used in crime prevention, surveillance, traffic enforcement, and public order. But in the beginning of the 20th century, motorized vehicles began to overtake the significance of the police bicycle. Using motorcycles introduced some problems like its contribution to air pollution, high maintenance, complexity, and high risk of being involved in an accident. We all know that nowadays, gasoline prices at most places, including the Philippines, are increasing, and our planet suffers largely due to the emission of motorized vehicles. In response to this, bringing back bicycle utilization for police operation is a very good solution. Besides the fact that biking promotes environmental awareness and health benefits to police officers, they are easy to maintain than traditional patrol cars and motorcycles. Bicycles also contribute to the mitigation of the air pollution and the improved progress and strategy of police activities. The bikes also permit the police officers to move freely and easily to perform their duties with a peaceful means and to roam through traffic without difficulty since they can be able to navigate through sidewalks and alleys.
Generally, we aim to present an alternative and more comprehensive utilization of patrol bikes with its improvised features on safety, cost, fitness, sustainability, environmental friendliness, and mode of transportation. You might want to ask what is the difference between the normal or traditional bike with this electronic bike. From its name, we will be using electronic technology in performing its improved features. To begin with, let's enumerate the different hardware used in carrying out its functions with their respective requirements. First, a standard bike dynamo generating around 20 volts AC. A bridge type rectifier voltage regulator inside here that should be able to regulate the supply of 6-volt DC for the modules. A battery charger shown here as part of the power supply. A command center, which is a personal computer with an operating system released not earlier than Windows XP. Switches used for the flashers, stoplights, and hazards as shown here. Timer circuit providing 1 second delay. Microcontroller with at least 16 kilobytes of flash program memory and a minimum of 10 input-output pins. GPS that must receive the data from GPS satellite for at least 2 minutes and accuracy of 10 meters maximum from the actual position. GSM that must be able to send the information to pre-configured server in the shortest possible time. It should also cover wide and unlimited range, where its coverage and range is within the network providers to ensure reliable and stable communication path. The signal lights that should be composed of high-intensity LEDs, about 6 to 8 lumen, inside here and also here. That must be arranged according to color. For example, red for stoplights, yellow for hazard, and signal lights. Last but not the least, the LCD that should be any display device, either 16 by 2, 16 by 4, or organic LED to indicate input voltage of about 5 volts and brightness of about 40 nits. On the other hand, software requirements include first, SMS program, which is the microcontroller module must have a program to transmit and receive text messages. It must be capable of transmitting and receiving at least 16 characters. The GSM module is interfaced to the microcontroller module for the SMS program. This program must be compatible to the microcontroller module. Second, GPS program. The microcontroller module interface with the GPS and GSM modules must have a program to locate the biker's location and send the required data to the command center. The program must be compatible to the microcontroller module. And third, mapping program. The received coordinates from the bike in patrol must be plotted and interfaced with the mapping software in the command center for continuous monitoring of bike patrol team. This program must be interfaced with the PC and the GSM module. Now that the hardware and software of our system have been discussed, I am going to demonstrate how the e-bike is working.
So what we're showing now is the actual demo of our system. As stated earlier, we have the dynamo which produces around 20 volts AC when the bike is being pedaled. The AC indicator varies with how fast the dynamo is spinning, brighter for fast and dimmer for slow. This AC is converted to a DC supply that charges the battery pack without having to use an AC outlet. The concept portrayed is to produce electricity from pedaling and store them in rechargeable batteries. To use this battery pack, we just place the batteries and flick on the switch which powers all the components of the bike, starting with the buzzer. We have the front lights for visibility to incoming vehicles, namely the park lights and headlights, high beam and low beam, the left turn signal, the right turn signal, and the hazard lights for emergency. For safety of the rider, at the rear end of the bike we've installed lights similar to the front lights. We have the left and right signal turns, the hazard lights for emergencies, and the red brake light to inform vehicles or riders from the back that you are slowing down. Let's now see the bike in action. Aside from the lights and buzzer or horn for safety, as stated earlier, we've installed an LED used as a digital speedometer to monitor how fast the rider is going. This was possible with the help of the microcontroller and the rectifying circuit of the system. Since the use of a bicycle is also a means of transportation, we've installed the bike with a GPS module as well. With this, the command center is able to trace where the bike or rider is. As shown in the video, we are tracing where the rider is now. To summarize the key features of this e-bike, it is of course a mode of transportation. It promotes environmental friendliness and energy sustainability. It cuts the cost on fuel consumption. It helps in keeping you healthy. And for this e-bike, it provides more safety to the rider. The team sees potential that the e-bike could once again be used for patrol purposes or even more. The team recommends that there should be allotted bike lanes to promote more people to ride bicycles that promotes health benefits, cutting of costs, environmental friendliness, and with the setup of the e-bike, it also promotes energy sustainability. Also, we recommend and encourage other people to indulge themselves in this project by creating programs or softwares, since we use an open source prototyping platform which is the Arduino. Thanks for watching.